Okay, this lecture is going to talk to you about Chapter 10. Chapter 10 helps us look at budgeting a little bit differently. In budgeting, we talked in generalities of it's supposed to be so many pounds of material for a product. We're going to look at exercise 31. It's on page 461. Let's put that up here. Exercise 1031. Page 461. It's very close to the bottom of the page, so you might have to look a little bit to figure out where I got some of this information. It is so far down in the bottom of the page. This company makes apple juice, and they have figured out that it takes 128 ounces of the raw material, the direct material, at 5 cents an ounce to make apple juice. So we call that their standard cost, what they expect it to cost for each of these things. We're going to try to compare that to what it actually costs and find out if they varied from the budget. That's where we get the title Variances. The whole thing this chapter is about. So as we turn the page, 462, it tells us that during this week, we made 20,000 gallons of apple juice. We can do a little math. 20,000 gallons of apple juice times 128 ounces per gallon tells us how many ounces we need. It doesn't like my comma in there, but we'll put a comma in there now. We're going to need over 2 million ounces in order to make the production that we made. And remember, each ounce is supposed to cost 5 cents. So if we take that and times it by 0.05 and then tell our lovely system that we're wanting to show it as money, we're estimating that it should have cost them $128,000 for direct materials to make the 20,000 gallons they made this week. Now we're going to go to the other end of the spectrum and look at what actually happened. And according to our problem, we used 2,650,000 ounces, and we paid 4.5 cents an ounce. Yeah, don't want that to round up there. So we can figure out what our total cost really was. And we spent $119,250. Well, let's see how that compares. 119,000, 128,000. We were better than the budget. If you look at the standard cost as budget, we thought it was going to cost 128,000. We came in under budget. So we would say the total materials variance, and we would subtract the two. 128 minus 119, and we have to give a label to this. Fancy way of saying, is it good news or bad news? And we call this a favorable variance because we're happy about it. It's favorable. And as you can see, I've got all these other boxes in here, so there's more to the story. Why is our variance favorable? Was it because we just were so efficient and we used less ounces of raw material? Or was it because we paid less for the raw material? Or was it a combination of both? So if we go up and look at our story, 2,650,000 ounces, and we were planning on only using 2,560,000. Those numbers look really, really similar. If you stare at them for a second here, I'll put commas in, it might help. 2,006,000, 2,005,000. That's bad news. We used more ounces of raw material than we were planning. But somehow we were still able to save money. The reason, of course, being that we spent less for each ounce. So we saved money by spending 4.5 cents an ounce instead of 5 cents an ounce, but we used more ounces. So how do we show that? Well, we have two boxes. One down here is going to be called the price variance. So we're going to talk about the fact that we spent 0.5 cent less per ounce. And here we're going to talk about the usage variance, how many ounces we used. In the middle, to help facilitate this process, we have something that says standard price times actual quantity. Sounds complicated, but really saying is 5 cents, our standard price per ounce, times the actual quantity of ounces that we used. So I'm stealing the price from the standard side and the quantity from the actual side. And we come with a dollar amount here. 0.05 times 2,650. And if we had bought the quantity that we bought at 5 cents an ounce instead of 4.5 cents an ounce, we would have spent $132,000, more money than we really spent. That'll help us determine the price. Our price variance compares this and this. The price we actually spent and the price the standard says. And that's $13,250 that we saved because we were able to pay the lower price. So that's favorable, which you knew already. You knew we were in a favorable situation when it came to price. Now let's look at usage. Supposed to use 2.5 million, used about 2.6 million. That's not good news. The 2.6 million is also reflected here. So this variance usage is going to be the comparison of the standard 5 cents for the actual number that we used versus 5 cents at the planned number of ounces. Now you get a $4,500 variance, and we know that was unfavorable because we used more ounces than we were planning. Now, how do we make sure we've got the right numbers here? When we combine these two, you can look at unfavorable as a negative and favorable as a positive. And sometimes they will actually show them with parentheses around them. But when we take a favorable and an unfavorable and subtract them from each other, what do we get? So 13,250 minus our bad variance, and sure enough, we get our total variance. So we know we're okay. We have accounted for the whole $8,750 variance and broken it into its two pieces. And that's what the exercise asked us to do. Your homework exercises are going to do the same thing. You were assigned exercises 28, 29, and 30. They all deal with the same story problem, the top of page 461. So the same page we started at. You have the rest of the page to do. It involves material variances and labor variances. And we haven't talked about labor variances yet, but they're very, very similar. So this won't take very long. Start with the same kind of spreadsheet we were using before. We'll call this labor variances instead of materials variances. And again, we're going to compare actual and standard and come up with the total labor variance. Oh, we're going to find a problem to do this with. So if we turn the page to look at exercise 32, They produced bicycles. During the year, 660,000 wheels were produced. Sorry, they produced wheels for bicycles. The actual labor was 360,000 hours. So I'm just filling in as they start telling me things. That's the hours. And we spent $9. We paid the people $9.50 per hour. So I got enough information to know what we spent. And of course, like everything else, things don't fit like I want them to. There we go. So our labor cost that we actually incurred were 3.4 million. But as we read along farther, it says that every wheel should take us half an hour and should be $10 an hour. I'm gonna drop my $10 in here because I don't know how to do that one. Now, half an hour per wheel. Well, it tells us we did 660,000 wheels. And I want to times it by half an hour for each one. So it should have taken us 330,000 hours. We spent a lot more time than that. But the good news is we spent less per hour. So if we multiply these out, we should have spent 3.3 million. We spent 3.4 million. That's not good news. 3.4 minus 3.3. Yeah, it would help if I did it right. Okay, coming down here and saying 3.4 minus 3.3, and our variance is $120,000. Now, is it favorable or unfavorable? You're probably figuring this out way ahead of me and are already bored. We actually spent more than we were planning to, so that's unfavorable. But just like before, there's two elements to it. Is it the fact that we used more hours, or did we spend more money per hour, or what caused this variance? And we're going to build the same diagram you see on page 449. This side, instead of being price like it was for materials, we're going to call it labor or a rate variance. I'm just going to take off the word labor and make it fit a little better. And then here, instead of quantity or usage variance, we're going to call it an efficiency variance, meaning how efficient were we with the time that we had. The middle is just like before, standard. We don't say price, we say rate times actual quantity, or actual number of hours used. So if we look at the math for it, it's standard rate of $10 times the actual quantity of 360,000 hours. So the standard here says that we should have spent $3.6 million. Go. Now, the left box, the rate box, is going to compare this left and the center. And I like to do the bigger one first so that the numbers don't end up negative. But I have to make the decision on whether it's a negative result or a bad news result or a good news result. Well, if we look at what we're comparing, this number represents $9.50 times 360. This represents $10 times that same 360. So the only thing different between the left box and the center box is the rate per hour. And the rate per hour was better than we had predicted. So that's favorable. Here we're comparing $10 an hour, $10 an hour. The only difference is how many hours. So our difference here is all based on the number of hours, and this was unfavorable. And when you net out a favorable and an unfavorable, you have to subtract them, and they do come to $120,000. That's it for Chapter 10. You are done. You're able to handle the information and the problems. There's more in the chapter. So if you're reading things in the chapter and feeling like, I don't remember her covering those in the lecture, that's because we aren't covering them. We're not going to do journal entries related to it. Pretty much focus on the materials variances and the labor variances, and you've got it. I'm going to make separate lectures for the 3 chapters. Makes it a little easier to watch and a whole lot easier to download and upload for me on my end as I prepare these. Let me know if you have any questions.